already gone through the problems?
Some of are, ma'am, very confusing.
Yes, ma'am. Very, very confusing, ma'am.
Okay. Okay, we will check them. Yeah, my screen is visible, right?
Yes, ma'am.
Okay. So I think last day it was your summary session for week 8, and two more thing was still left to cover, right? L hospital rule and linear approximation, if I'm not wrong, right?
Yes, ma'am.
Okay. So is there any other problem other than this two concept? I mean, related to concept.
No, ma'am.
Okay.
Question problem, ma'am, have happened with me.
Yeah. Okay, we will discuss questions in this session mainly. But before discussing questions, I will just introduce these two things. First is a hospital rule, which maybe is like nothing new to you, but still, maybe some of you are there who don't know about it. So I will just cover it. And the second thing is linear approximation. Okay. So what is L hospital rule? This is a rule. Using this type of rule, we can solve a special type of problem, right? So sometime we can see we had some function fx such that if we just take a limit, some limit, some extending to a fx. So if we put a instead of x here, then sometime we may got you can like you can hear me, right? And you can view the screen also, right?
Yes, ma'am.
Okay. If not, then just let me know, okay? And
Okay, ma'am.
if you have any problem, then just unmute yourself and ask it, because maybe I will not be able to see the chat, okay?
Okay, ma'am.
Yeah. So yeah, sometime if we just put a directly instead of x, then we may get some type of this type of form, plus minus infinity by plus minus infinity, or minus infinity plus infinity, any combination of infinity, right? So this type of forms are called indeterminate form, right? And if you get this type of form, then we can use L hospital rule, okay? And what is the L hospital rule? This says that if x y g x, suppose, so this limit will be same as extending to a f dash x by g dash x, right? That means whatever function is given, you just take a derivative this two function separately, and the limit will be same. If after doing the derivative, suppose again you are getting 0 by 0 or this type of form, any indeterminate form, after putting a instead of x, then again you have to follow the L hospital rule, and then this derivative will be same as f double dash x by g double dash x, okay? So you can repeat this process until when you are getting the solution. I mean, something finite, something possible finite, if there exists a finite limit, okay? So this is basically L hospital rule. It's just a rule which says a functional limit will be same as the limit of its derivative, okay? Yeah, you just take it as a formula. Just have to apply it for your questions, okay? And the second thing is linear approximation. So linear approximation is, I guess it's clear from the term linear approximation that then it will be approximate to some given curve at some neighborhood near a point, right? So if just yeah, just let us observe it graphically. So if this is a curve, suppose we know that the tangent is a tangent of the curve at some point is just a line which touches the curve at that point, right? Suppose this point is A. Okay, so this line, the line T, is a tangent to the curve C at the point A, right? You know already this type of thing, right? So if we just closely observe the tangent, you can observe that if we at the point A, the line and the tangent will give the same value, right? They will basically, because the tangent the tangent T, it touches the curve at C. So at the point A, the value, that means C of A, will be equals to T of A, right? It's clear, right? Because it touches the curve at the point A, right? So if we just now check in a close neighborhood of A, that means in the points which are close to the point A, okay? So in this close neighborhood also, you can see that this portion, that means the tangent T, is almost same to the curve C, right? That means in some neighborhood of A, the curve and the tangent are basically same. So we have a random curve. We don't know what is the equation of the curve, but still we can approximate the curve linearly near some point. Okay. So because we are approximating a curve linearly near some point, that means what? In this portion, this is a part of the domain, right? This portion is a part of the main domain, right? So in this portion of the domain, we can we can find, or we can classify the curve, or we can find part of the curve using the tangent T, which is basically the linear approximation of the curve near the point A. Okay, so this is called linear approximation. Basically, linear approximation means we have a random curve and we are approximating the curve with some straight line near a point, like in a close neighborhood of a point. Okay, so is it clear to all of you? What do we mean by linear approximation?
Yes, ma'am.
Okay, fine. So I will just solve.
And we can say that the point A is a critical point.
No. I mean, if you want to find the linear approximation, so you can find the linear approximation at any point. Okay, and critical point means it will be either a maxima or a minima, or it will be a saddle point. So what is a critical point? Critical point is by the definition, if we have a curve C, then C dash at A will be 0 if A is a critical point, right? This is by the definition, right? It was the definition of critical point, right? Right. If you have a curve, the tangent of the curve the tangent, the slope of the curve at the point A is 0. That means if you have something like that, okay, then the slope is, the tangent is this line, right? Clearly, this is parallel to the x-axis, right? So what is the slope? Slope is the angle between this line and the x-axis, right? Which is 0, right? So if this is our point A, then at this point, suppose this is the curve C. So at this point, the derivative, that means the slope of the curve at the point A is, right? Because the tangent is parallel to x-axis. Okay. So at this point A, you can see this is the tangent, right? And this is our x-axis. And this is the angle, theta. This is our slope. Okay. I mean, this is tangent and slope is m equals to tan theta. Okay, clearly this angle is not equals to 0, right? So if the angle is not 0, then the point is not a critical point. That means you can find the linear approximation of a curve at any point. Okay, but if it is a critical point, then at the point the tangent will be parallel to x-axis. Okay.
Here, in the second case, if we put tan 0 equal to 0.
Yeah, because this is the angle, right? This is the tangent, and this tangent is clearly parallel to the x-axis, right? So because they are parallel, so the theta is 0 here, right? And what is the slope then? This is basically m equals to tan 0, which is 0, right? So this m is basically nothing but the derivative of the curve at the point A. Okay, is it fine?
Yes, ma'am.
Ma'am, give a
Okay.
short note, linear approximation. It's not fine, ma'am.
Yes, can you repeat? I just missed your word.
Oops. Yes, ma'am. Can you repeat the explanation of later as a short about the linear approximation?
Okay, so linear approximation means suppose you have an unknown curve. Okay, so you don't know anything about the curve in it, like the equation or how it will behave. You don't know anything about the curve. Okay, but suppose you want to predict something about the curve. Okay, something, it may be anything. So what you can do, just suppose we want to calculate, we don't know what is the curve. Okay, and we want to calculate the slope of the curve at a particular point. Okay, then how can we do that? We can approximate the curve linearly, and then we can find the slope. Okay, so basically linear approximation, the slope for the linear approximation and the slope of the curve will be same. So the linear approximation is nothing but tangent of the curve at that point. I mean, you just note this. Linear approximation of a curve C at a point x equals to A is nothing but tangent of the curve C at x equals to A. Okay? So linear approximation is nothing but the tangent of the curve at x equals to C. Okay. So just if you have a random curve, suppose this point at the point A, you want to calculate the linear approximation, it is nothing but the tangent at the point A, which just touches the curve at the point A. Okay, so linear approximation is nothing but the tangent, and the equation for tangent and equation of linear approximation is basically same. And suppose you want to predict some value of the curve near the point A, it will be approximately same as the linear approximation of the curve. Okay.
Okay, ma'am.
So in this picture, you can see in this interval, the tangent T, this is a tangent T, and this is a curve C. They are almost same, right? So suppose this point is A plus epsilon. This point is suppose A minus epsilon. Epsilon is a small number. Okay, epsilon is greater or less than 1. Okay, if we just plot this in the domain, this is our domain. Okay, so this point is A, this point is A minus epsilon, this point is A plus epsilon, right? So suppose I don't know what is the equation of the curve, but suppose you want to calculate some C of A minus A plus delta some point here. Okay, delta. Okay. So because you don't know what is the equation of the curve, so you cannot just directly put this thing in of x and calculate value. So in this case, what can we do? We can calculate linear approximation, and then we can put this A plus delta instead of x in the linear approximation. So the linear approximation, suppose L, this is the linear linear approximation of C near the point A, okay, then if we take any point, any suppose beta belongs to A minus epsilon, A plus epsilon, that means from this function, if we take any point, so L of beta, that means the functional value of the linear approximation of at the point beta will be approximately same to functional value of the curve at the point beta. Okay, motto linear approximation. Okay, for some unknown curve, you can still predict the value at some given point by calculating approximation. Okay.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, could you please repeat after the epsilon part?
Okay, so it's simply, I mean, can you hear me now? Hello?
Yes, ma'am. You
Yes,
are audible.
ma'am. Yeah. Now the screen is visible, right?
Yes, ma'am.
Yes, ma'am.
Please repeat.
Yeah. Huh. So I just mentioned epsilon just to apply it mathematically. A point A minus epsilon is very like a point which is really close to the point A and a little bit small to the point A. Okay, that means this is the point A. Suppose let me use another color. Okay, so this red point is suppose A, and this another red point is your A minus epsilon. Okay, so this is a point which is near to the point, very close to the point A. Okay, similarly this point is A plus epsilon, which is again a point which is very close to the point A, but it is greater than x A. Okay, so in this case we just took this interval, and in this interval the curve and the tangent, that means the linear approximation, are basically almost same, not exactly same but almost same. Okay, so in from interval, that means this interval, this A minus epsilon, A plus epsilon, this interval is nothing but this portion of the domain. Okay, this portion of the domain, just this portion of the domain. Okay, so this is our A minus epsilon to A plus epsilon. Okay, so in this portion the linear approximation and the curve is almost same. That means if you take any point from this portion of the domain, so the value of the tangent and the value of the curve at that point will be almost same. Okay, and we use this sign to mention that the value are almost same. I mean, they are approximately equal. Okay.
Ma'am, the point epsilon you are saying, right? That is the center of the point A. From there, you are taken some one point above and one point below. That is you are taking that point randomly, right? There is no.
Yeah. This epsilon is a variable. I mean, this epsilon is a really small number. It can be very close to 0. Okay, so it depends basically over the curve. I mean, curvature of the point. Okay, I mean, if the curvature is this, okay, then the epsilon will be small, right? But if the curve is almost flat at that point, then the epsilon can be bigger than the previous one, right? So this epsilon is nothing fixed, it's a variable. I just I just wrote it to mention that like I want a small neighborhood around the point. Okay, so I mean, the small is not something well defined. I mean, it can be so small, it can be little bit So it's depend on the curvature of the curve at that point. Okay. So yeah, is it fine? Or if you have any doubt regarding the linear approximation, you can ask.
No, ma'am, got it.
Okay, so it's clear to all of you, right? Like what is linear approximation and why do we calculate linear approximation? I mean, what is the use of a linear approximation? So it's clear to all of you, right?
Yes, ma'am. It's yeah. Got the idea too.
Okay, very good. So we will solve a problem. There are so many problems in your AQPQ using the linear approximation. We will cover those things. Don't worry. But yeah, just using the L'Hospital rule, I have, you know that this limit is 1, right? Limit intending to extending to 0. Sin x equal to 1. This we already know, right? Because we had the formula when we studied limit, right? But we can calculate this type of thing using the L, right? Because if we just put 0 instead of x, you can find it will be in 0 by 0 form, right? Sine of 0 is 0 and x is 0, that means 0 by 0 form, right? So we can clearly apply the L'Hospital rule in this type of case. So what we will get, what will be the next step then? Anyone?
Differentiating, ma'am.
Limit? Yeah.
Cos x will become cos x 0 equal to 1.
Cos x by 1, right? And this is similar, just simply cos of 0, which is 1, right? One more form you have used it, I guess. Log of x plus 1 by x to 1. Am I right? Is it the formula? Is it the formula? Any of you?
Yes,
Do you
ma'am.
remember?
Yes, ma'am. It's 1 plus x, but no problem.
Yeah, I
plus
mean
one.
x plus 1 and
Yes,
1
ma'am.
plus
Both are
6.
same, no problem.
Yeah. So again, if we have this type of thing, so this formula also can be proved using the L'Hospital rule, right? So again, this is in 0 by 0 form, right? Log of 1 by 0. That means 0 by 0. Yes? Yes?
Yeah, this
Okay,
formula,
okay.
ma'am. Last one.
Yeah. Yes. So this again in 0 by 0 form, right? So again, we can apply the L'Hospital rule. So this will be limit extends to 0. What is the derivative of log x? 1 by x, right? So it will be 1 plus x, and the derivative of x is 1, right? So this is nothing but limit extending to 0, 1 over x plus 1, right? Which is 1 plus 0 plus 1, that means 1, right? So these things are
Yes,
quite
ma'am.
easy, right? So if you get this type of form, 0 or infinity by infinity, or minus infinity by plus infinity, any one of this, then you can just simply apply the L'Hospital rule. Okay. So yeah, we will solve more problem, but before this, let us move to the activity questions and all the questions. You had some problem with the questions maybe, right? So what was the doubt?
And what is this L'Hospital rule?
L'Hospital rule, I just explained. Okay, just let me go through it again. So this is the L'Hospital rule. If you get this type of form, I mean 0 by 0 or plus minus infinity by plus minus infinity, in this type of form, you can use L'Hospital rule. And L'Hospital rule says limit extends to a f of x by g of x will be equals to limit extending to g dash x. Okay. Okay, this is the L'Hospital rule. If this function is in this form, I mean, if you put x in a instead of x, and after putting this, if you get 0 by 0 or plus minus infinity by plus minus infinity, then you can follow this step. In the next step, you can directly equate the limit as a limit extend to infinity with the derivative of the given function. Okay.
Only the derivative of first f.
Both the function, I mean f dash x by g dash x. Okay, just
We'll take double derivative.
no, not double derivative. This is the function g of x will be equals to limit extending to a f dash x by g dash x. Okay.
Okay. Okay, ma'am.
Yeah, so this is the formula. So yeah, it's this two concept, L'Hospital rule and linear approximation. These are clear to all of you, right? This is clear. Then we can move to the question solving problem.
This is ma'am, but you said the f the double quote, the double dash zero.
Okay, I just told ki if after following this step, I mean, suppose you have f by g, and you suppose after putting a, you are finding 0 by 0 or any indeterminate form, then in the next line you can write limit extending a f dash x by g dash x, right? Then suppose again if you put a, then you may get again an indeterminate form. Then you can just follow this step. I mean, then again if f dash a by g dash a, this is in indeterminate form, that means any of this form 0 by 0 or plus minus infinity by plus minus infinity, then you can again apply L'Hospital rule, and in the next step you can write it as the double derivative of the function. I mean, again this is the new function, right? F dash x is a new function and g dash x is a new function. So again you can derivative the function using the L'Hospital rule. Okay, if it is in the indeterminate form. Okay.
Okay.
And why this L'Hospital approach is valid for this mathematical purpose? Because we are getting something indefinite and we are just going with differentiation and differentiation until we get something definite. So this isn't it kind of against the rules of solving any equations?
No. This is not against, because see, here this concept is about limiting concept. No, so we are not directly putting a here. Okay, I mean we are taking something which is close to a. Okay, the function is not defined at the point a, but it is defined near the point a. I mean something which is close to the point a. Okay, so if we are doing, I mean, when we are differentiating the function, we are again calculating the linear approximation. Then we are finding the limit of the point near the point A. I mean, if it is not at the point A. Can you get my point?
Yes, ma'am. Yes, ma'am. Got it.
Yeah. Okay, so up to now, I mean, these two concepts are fine, right?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
all of you are okay with it, right?
Yes.
Okay, fine. Then we can move to the problem. Now, let me know what are the problem you're facing.
Fifth
in
question, ma'am, in this activity 8.1.
8.1, question number 5.
Yes, ma'am.
Okay. Okay. So yeah, what is the issue here?
Like, I'm not able to understand what is f of x. Like, I couldn't understand the question properly. Like, what is it relating to?
Okay. So what is given in this portion? Continue. Okay, these are just the definition. So nothing to say. Check here. Okay. Okay. So the question is, there exists a continuous function f from 1.5 to 1.7 such that f of 3 equals pi Okay.
Ma'am, here that 1, 5 and 1, 7 is to be taken as domain and codomain, right?
Yeah, yes. I mean, form something means this is the domain, and to something means this is the codomain. Okay. It's a continuous function f from this to this such that this. Okay.
Ma'am, what is the meaning of form? Is it used for range or codomain?
Okay. So form means domain. Okay. I mean, form something means this is your domain. Okay. And to something means this is your codomain. Okay. Form
Yes, ma'am.
domain to codomain. Okay. So this is again domain. This is domain. This is domain. Okay. Is it fine?
Yes, ma'am. Yes.
Okay. So yeah, let us do this. Okay, so for the first option, clearly we can just like hit the option with a counter example. I mean, pi is something less than 7, right? Like pi is something even less than 5, right? And greater than 1.
Yes, ma'am.
3.14 something, the approximate value, right?
Yes, ma'am.
So if we take the function from 1, 5, I mean, from this interval as a constant function, so we can get a continuous function which can give this value, right?
Yes, ma'am.
Yeah. So for the first option, clearly we can just conclude. I mean, we can just
Okay, ma'am, is
at
it like we have to check codomain and domain? Like, is it bounding in the sorry? Does it come under them? Is that the meaning of the question?
I mean, can you repeat?
Like, we have to check is if f of 3 is pi comes under 3.14 such that it comes under 1, 7 between 1, 7.
Yeah. First of all, this is the my first point to being a function, right? So obviously this should be the case. And the second thing is you have to check whether any characteristic of a continuous function is affecting by this statement or not. If not, then it's fine. If it's the case, I mean, if there is any problem with some property of the continuous function, then you may have some counter example. I mean, if you want to disprove something.
Okay, I understood the question, ma'am.
Yeah. Okay.
Yeah, no need to continue with other options.
Okay.
Sorry, ma'am. Actually, I have a question here.
Ma'am, I also have a question in this activity, question number 3.
Yeah, can I ask a question, ma'am?
Yeah, sure. One by one, you can ask, then we will.
Yeah, actually, it is on the same point where when you mentioned one domain 1 and 5 included, map to codomain 1 and 7 included, right? So
yes.
This
Closed interval.
mapping of between closed interval 1 to 5 to mapped interval 1 to 7, that is meaningful, that is understandable. However, nowhere it is saying that for the input 3 it is mapping to pi. As we don't know the exact function, it is hard to say that, you know.
In this, we don't need to know the exact function. I just told you the particular constant function because there exists a continuous function for this word. There exists a continuous function. I mean, I have something in my mind. I mean, I have some example, direct example. Okay, we know that the constant function is continuous, right? So the constant function is a direct example of this. So there exists, it will satisfy the particular word there exists, right? That is why I just told you about the example. Am I clear?
So
am I clear? I mean,
we don't need to prove that there is a function exists such that
Yeah.
f of 3
Same
is pi.
question.
Okay, I mean, see, if you have directly, I mean, any example in your mind, then this is itself a proof. I mean, you have a function, so it will satisfy automatically. I mean, it will automatically satisfy the line there exists a function, because you can find an example. That means you have an example, so this function exists, right? So it will automatically satisfy the proof. I mean, if you have some example in your mind, then no need to prove it.
Okay.
Okay, we just have
Yeah.
to prove that this statement is true, right?
Yes, just you need to prove that statements is true. That means if you have example, that means obviously there exists a function. Am I clear with the thing?
Yes, ma'am, got it.
And
Okay.
sorry, one more question.
Yeah.
So the third option and fourth option, they are saying about bounded function and unbounded function. So what is the
Yes.
difference between these two?
Okay, so bounded function means you know about bounded below and bounded above, right?
Yes.
Yeah. So bounded function means it's both bounded above and bounded below. That means there is a lower bound and upper bound for the function. Okay. That means suppose, just for example, the function of sin x. Okay. So this function is like that, right?
Yes.
So the domain is whole R, but
Mm.
the function is bounded. I mean, it will never cross -1, and from the positive side also, it will never cross +1, right?
Correct.
So the function is basically bounded above by +1 and bounded below by -1. Okay. So this is a bounded function. And
No,
suppose,
that's where my question is. So if we have any function, okay, we can
yes,
say that it is bounded by so and so, limits, or so and
yeah,
so maximum and minimum value. But when they are
yes,
saying mapped, I mean, f of function f is matched from R to R, which is bounded, means always it is true, right? Because we are dealing with the
yes,
functions
yes.
where,
Yeah, there are so many examples of a function, I mean, which are bounded and from R to R.
okay,
Because
in
R
that we
is
need to
here
know
your
that, okay, there is
codomain.
some
This is the
non-continuous function
codomain.
also. Okay.
Yeah.
Oh, that way. Okay.
This is the codomain, not
Okay.
range. If it were range, then this is never bounded.
Yeah,
Just take this as domain and codomain. Okay.
Okay. Yes.
Yeah.
Okay, that way. Okay, fine.
Yeah. So this
Now
is an
it,
example, right? If you take sin x or cos x, so these are non-constant continuous function from R to R which are bounded, right?
yes.
Yeah. So yeah, don't take it as yes, huh?
Yeah, ma'am, that question, option 3 and 4, in which you said that from R to R is bounded. This basically tells that if you are going from if you are taking the domain as infinity, your function also goes to infinity, right? From R to R.
No. Yeah, this is the difference. I mean, if the R is a range, then this is another. I mean, here some form and 2, we are basically meaning as domain and codomain, not the range. Okay.
Not the range. Okay.
Yeah. So
Okay,
you
then
can
how-
use the R as codomain of sine function 2.
Okay. Then the option 4, which is also marked as a green, then that does not make sense, right? Then it
Why?
says it's an unbounded continuous function from 2 to 3,
Yes.
leave 2. So to then how come it is an unbounded now? I mean, that's what I did not understand.
I mean, again, the word there exists. There exists some function. I mean, if we just draw, suppose this is our 2 and this is our 3, okay? So we can draw a function like that, which are going to infinity and minus infinity at 2 to 3. So this graph you can follow, right?
Yeah.
So this graph is a graph of a continuous function, right? From 2 to 3, 2, 3 to R. Correct? And this is a unbounded continuous function. So there may be so many type of thing, like this is also one example.
We can then also say a statement that there is just a bounded continuous function between 2 to 3 to R. because it's all about hypothetical space that we are just talking about here. That between this, there can be a bounded continuous function, there can be unbounded
yes
function, correct?
definitely there can be a bounded function, but we need to focus on this what there exist. I mean, there may be some function, I mean, not necessarily all the function from this to these are unbounded, but there is some function which are unbounded in this, from this domain to this codomain.
Okay. This question
Ma'am,
is very
ma'am,
tricky.
ma'am,
Yes.
could you please give me an example when there does not exist any function between this range? Likewise, there are 4 options. If we increase the options, if there is any condition that the function does not exist?
Okay, suppose we have this domain and codomain. Okay, and if the option is there exists an unbounded continuous function from this to this, I mean, just take from this, then the domain as this and codomain as this.
Okay, ma'am.
Okay, clear? So clearly this
Yes,
is the
ma'am.
codomain, so the functional value will never cross this 1,7, right? So this is bounded, the functional value is bounded above by 7 and bounded below by 1, clearly, right? So this cannot be unbounded.
Yes, ma'am. Yes, ma'am.
Clear?
Ma'am, is it also possible that for the 4th option, there exists a bounded continuous function?
Yes.
Is there any possibility?
Yes, definitely. Just take the, I mean, you can draw some random continuous function also. This is a function. Just,
Ma'am, if we go through this point, then the statement 4 is incorrect, right?
no. I mean, if there is some function which is bounded in this domain and codomain, that doesn't imply that there doesn't exist any function which is unbounded in this domain and codomain.
Oh,
I mean,
okay, ma'am. Okay,
we just
got it.
want one example, and one example is in our mind, right?
Yes, ma'am. Yes, ma'am.
Yeah, you just want one example. There may be some function which are bounded, but also there are some function which are unbounded too.
Yes, ma'am. Yes, ma'am.
Got it?
Yes, ma'am.
Okay, so it's clear for all of you?
Yes, ma'am.
Okay. So what is the next problem with the third question, right?
Yes, ma'am.
Yeah. So what was the problem? We have to find number of discontinuity, right? So yeah, we just have to check at 1, right? And other than 1, we don't have any problem with the function. So if we have, always keep it in your mind that if you have this type of function, I mean, which are defined in 2 different or 3 different interval, then just check at the boundary points. Okay, so here the boundary point is 1, right? The function is giving 2 different type of thing, before 1 and after 1, right? So you just have to check the continuity at the point 1. Okay, so if the function is discontinuous at 1, then the number of discontinuity 1, and if the function is continuous at 1, then the function is continuous everywhere, right? Because we don't have any problem with other points other than 1, right?
Yes.
Yeah, so am I clear? And now can you solve it? Just check the continuity at the point 1, just by the definition. Okay.
Okay, ma'am.
Yeah, can you now you can solve it by your own, right?
Yes, ma'am, I can try.
Yeah, just try it. It's not difficult. You just have to calculate the limit, like right hand limit and left hand limit at the point 1, and just check whether it is equals to the point f of 1 or not. Okay.
Okay, ma'am.
Ma'am, it's a
there
simple
is-
question. Yeah.
Ma'am, there is
Yes.
this word written that number of discontinuity, ma'am, in function of f.
Okay.
Ma'am, breaks of, ma'am, break in graph.
Number of discontinuity means, I mean, number of point at which the function is discontinuous. Okay.
What do you mean by that, ma'am?
I mean, discontinuous means which is not continuous. Discontinuous means not continuous. number of point at which f is not continuous. So we know that f is continuous everywhere. So we don't know about the point 1. Just check whether f is continuous at 1 or not. If it is continuous, then we can imply that if f is continuous everywhere, that means f is continuous at each of the point in its domain. So clearly number of discontinuity, that means number of point at which f is not continuous is 0, right? Because f is continuous everywhere in the domain, right?
Yes, ma'am.
Okay. Just you got my point, right?
Yes, ma'am.
Ma'am,
Okay. Yeah.
ma'am, you are saying that and just check it on one that it is continuous or not. But what if
Yes.
the first sign will change that x is less than equal to 1, x divided by x plus 1, x plus 2? What if the first sign will change? Both of the sign will change. X is less than equal to
Yes.
1, so
Okay. If you are saying that if the value x by x plus 1, x plus 2, if x is less than equals to 1, right?
yes, ma'am.
Okay, then the function itself is not defined. Check at the point -1.
-1 and -2.
Yeah.
Yes, ma'am.
So -1 and -2, the point is not defined. That is why they define the function in such a way, so that we can define the function in all over the domain, right? So the first of all, it should be a function. If we define this as x less equals to 1, then this is not even a function. Okay. I mean,
Yes, ma'am.
for a function, we should get a unique value for each input, right?
Yes, ma'am.
Yeah. Okay. So is it clear now?
Yes, ma'am.
Okay. Okay. Very good. Yeah. Next out. Yes.
Ma'am, 6.2.
6.2.
Seventh question,
6.2.
option number B. Could you explain? 7.2. Sorry, 8.2. Seventh question, option number B.
Okay. So in 8.1, any one of you has any doubt? Or then we can move to 8.2.
Second question.
In 8.1. Second question. This one.
7, ma'am. 7.
This one.
Yes, ma'am.
Okay. So this is again a simple question. I will give you hint and you have to just try it by your own. Okay. So if it's given that this function is continuous at the point, at all the point, okay, that means this function is continuous at 0, right? And by the definition, what do we know? If it is continuous, then the left hand limit, that means extending to 0 minus f of x, will be equals to f of 0, and this will be equals to limit extends to 0 plus f of x, right? This condition we have by the definition. And also tan inverse x by x, limit extending to 0, tan inverse x by x is 1. This is a formula. Okay. So just use this to think and then just solve this problem and you will get the value of a plus b. Okay. This is the hint. Try to use the hint and solve the problem. Okay. This is pretty simple. That is what I'm not solving it. I just gave you hint and try to solve using the hint. Okay. Fine. Okay. So what was the problem in 8.2?
Seventh question, option number B. B, ma'am.
Seventh question, option number 3.
B. Option number
B.
Bombay.
Inverse of a differentiable function is differentiable. This one.
Yes, ma'am. Like, could you explain why it is wrong?
Okay, wait. Just let us check the options.
Ma'am, are you talking or?
No. I'm
Okay,
not.
okay.
Yeah, I'm just thinking it. Why is it wrong? Okay, so if we check graphically, I mean, if a function is differentiable, that means we don't have any sharp corner. And inverse of the function is just something symmetric with respect to the line x equals to y. It should be also differentiable. Okay, just give me 2 minutes. Let me think about it. Just if there are any other problem in 8.2.
Last question, ma'am. You need not explain. No problem. If anyone other people have, please.
No. I will try to explain it. Just I want to think about it. I mean, I'm also not very sure about it. So I need to think about it.
Okay, ma'am. No problem.
Before that, yeah.
Please take your time.
Yeah, sure. So what was the next problem?
But if no one has any doubt, ma'am, 10th question. Like it's not. If you are interested, please. 10th question.
10th. This one.
Yes, ma'am.
Okay. Okay. So, okay, let us solve it together. Okay. This question is almost similar to the last 7th question at the point 0. Okay. So this is given that the function is continuous and differentiable at 1. Okay. That means we have extending to 1 plus fx equals to limit extending to 1 minus fx equals to f of 1 by the definition, right? Right?
Yes, ma'am. Yes, ma'am.
Yes. Now you just tell me what will be limit extending to 1 plus fx?
K plus L.
Just we will put 1
Sorry,
instead.
yeah, sorry. Yeah. L plus K plus M is equal to K plus L.
K plus L, right? Equals to f of 1 means again K plus L, right? Because we have equal sign here, so we will put 1 here. Okay.
Okay.
Yeah. So now we can cancel K plus L from both sides, right? So we will get M equals to 0 here, right?
Yes, ma'am.
Yeah. So we get one value, which is M equals to 0. So we have one hint. Now we will use another hint that f is differentiable at x equals to 1, right? That means limit h tending to 0 f x h plus 1 minus f1 by h. This will be something finite, right? That means, and 0 plus will be equals to limit h tending to 0 minus all this thing f of h plus 1 minus f of 1 by h, right? I mean, this limit will exist and it will be something finite by the definition of differentiability, right?
Yes, ma'am.
Yeah. So what will be this limit then? So h is tending to 0 plus, right? So h plus 1 will be tending to 1 plus, right?
Yes, ma'am.
So we will put h plus 1 where? In this equation, correct?
Yes, ma'am.
So we will get same limit h tending to 0 plus L h plus 1 square plus k into h plus 1, right? And m equals to 0, we know, right? And just f of 1 means k plus l, right? K minus l by h, okay? Now you just calculate the limit. So what will be the limit then? What will be the limit? Just calculate and let me know.
0.
Mm-hmm.
0, 0.
Yes, ma'am, it will be 0.
Why?
If we substitute
If
h,
substitute, then it will be in 0 by 0 form, right?
yes, ma'am, we can do L hospital
L
also.
hospital rule. So it will be 2L h plus 1 plus k, right?
Yes, ma'am.
After derivating,
Yes, yes,
2L
ma'am.
h plus 1 plus k. Then we can put 0 instead of h. So what we will get? 2L plus k, right? Is it clear?
Yes, ma'am. Yes, ma'am.
Yeah. And what will be the limit for this side? This will be equals to this limit. Again, h plus 1, and h is tending to 1, 0 minus, then that means h plus 1 will be tending to 1 minus. That means from the negative side of 1, right? That means from the left hand side of 1. So we will use this formula in that case, right?
Yes, ma'am.
Yeah. So again, it will be k into h plus 1 square plus l minus k minus l by h. So again, we will get 0 by 0 form, right? And if we
Yes.
just differentiate, then we will get what? Tell me what we will get.
2L plus K equal to 2K.
Okay. Is it?
Yes.
Okay. Okay. Then just take it in this side. So we will get 2k minus.
2L equal to K.
That means this, right?
Yes.
So 2l minus k, this is 0 and this
So
is
K
also 0.
minus 2L is 0. Yeah.
So this will be 0 in whole, right? The answer is 0. Okay. Fine.
Yes, ma'am. Understood, ma'am.
Yeah. Okay. Yeah. Any other doubt in 8.2? Any other doubt in 8.2?
No, ma'am.
Okay.
Only yes, that question only.
Yeah. Let me just think about it. Just give me 2 minutes.
Okay, ma'am, please.
Yeah,
Please.
yeah. If it's coming in my mind, then I will explain. Otherwise, I will try to explain it later. Okay.
Okay, ma'am. No problem.
Okay. So, so for this option, two things is coming into my mind. The first thing is maybe there is, I mean, they should mention it properly. I mean, because they haven't mentioned anything about the domain and codomain. That is why it is a like point of confusion. So if the domain and codomain are same, then for, I mean, for any function, we know that, I mean, for any function, the inverse of the function is just something symmetric with respect to the x equals to y line, right? So in that case, if the first function is differentiable, that means we can draw tangent for the function at any point. So again, we can draw the tangent for the inverse function also. So in that sense, if the domain and codomain are same, so in that sense, the inverse function is also differentiable. So here is an ambiguity. They should mention the domain and codomain, like then we can do something specifically. So if it is the case, then in that type of case, the function is differentiable. But I mean, suppose the first function, I mean, f is suppose, just for example, some 1, 2, 2 r. Okay, so the inverse of f will be some r2 1, 2, right? So in this case, we can take f as inverse of f inverse also, right? So in this case, the domain of f is 1, 2. So at the point 3, suppose, so at the point 3, this is a member of R. At the point 3, the f inverse is differentiable, but at the point 3, f may not be differentiable, right? So like if we like just vary the domain and codomain, then there may be some issue with the differentiability, because the function may not be even defined at that point. So it may not be differentiable at the point. I mean, it may be discontinuous at the point or anything else. Okay, so if the domain and codomain is same, then obviously this statement will be true. But because there are nothing given about the domain and codomain, so there are function such that, I mean, the function, I mean, there are some example of function such that for the function is differentiable, but the inverse may not be differentiable. I mean, we can take some specific example. Can I mean, I'm clear with the, I mean, what I want to say. Am I
Yes,
clear
ma'am.
with my word?
Yes, ma'am.
Yeah. So there are some cases at which this statement is true, but also there are some examples at which this statement may not hold, right? So if there are some example which can discard the statement, then we cannot say it as a general statement, right? This is what I mean. If we have one counter example, then you can discard the statement, right? So we will use this type of logic here. Am I clear with the word?
Yes, ma'am.
Yeah. So I think what you can do, you can just try to find some function which maybe may not be, I mean, the function is differentiable, suppose at that point, but the inverse function is not differentiable. I mean, there are some example. Try to find this type of function, just like changing the domain and codomain, like don't take them as same. Okay, just take this as, you can take this as some union of some interval also. Just try to find an example. Okay, so if you got the example, then you can let me know in the next class. If not, then I will also try to find some example, so I will present the example in the next class. Okay.
Okay, ma'am.
Yeah. Okay.
Yeah. No. Thanks for.
Okay. Yeah. Yeah. What
But
is the
in
next?
example, x cube.
Which one?
X cube.
Yes.
Its inverse is root 3x, and
Yes.
in x is equal to 0,
Correct.
it's sharp. Yeah.
Correct. Yeah, this is just an example. This should came into my mind earlier. So the inverse is what is the inverse? What is the inverse?
Root 3.
Root 3.
Cube root of 3, right? That means
Yes, ma'am.
that means
X
this.
power 1 by 3. Yeah, now it's clear for me. Yeah, thank you,
Yeah,
ma'am.
so it's not differentiable at
Yes,
1,
ma'am.
right?
Yes, ma'am.
Yeah. Very good for the example. Yeah. Okay. What is the next doubt?
If no one has any doubt, ma'am, 8.3, can you go, ma'am?
Yeah, sure.
In 7th question, ma'am, I guess it's a technical issue, or like in solve with us. Sorry, if we check the answers for this, I'm getting option A and B as the right answers for myself.
7th question, option A and B.
Yes, ma'am, I'm getting the answers, but option A is wrong answer, but option C is right answer. But if we do it in solve with us, like in the same week, the same question is repeated and A and B are right answers, but option C is violating L hospital rule also. If we solve, only please solve option A and option C.
Yeah, let us solve it. So clearly this is also in infinity by infinity form, right? If we just put infinity instead of x, this will be in infinity by infinity form. We will clearly then use the L hospital rule. So limit extending to infinity. So infinity by infinity form is this sine x will be something bounded, I mean something in between -1 and +1, but this x will give infinity and this x will also give infinity, right? So this will be in infinity by infinity form. So just apply L hospital rule, then we will get 1 by 1 plus cos x, right?
Yes, ma'am, we will be getting 1 by, yes.
Yeah. So then okay, so in which of the we can apply L hospital to equivalent limit? Okay, so in this problem also I think, I mean, if we put infinity, I mean here we don't have any like this type of thing, right? Like plus minus infinity or 0 by 0, right? But if we put infinity directly, then also you cannot determine the limit. I mean the cos x can be anything between -1 to +1, right?
Yes, ma'am.
So
yes,
this
now
thing
I
is,
understood. Yes, ma'am. Oh, sorry. In solve with us, it was like tending to 0. Like,
yeah. If it is
I
tending
was
to
now.
0, then we know the specific value.
Yes,
but
ma'am.
because here it is tending to infinity, so we don't know what is the specific value, but it can be anything between -1 to +1, right?
Yes,
so
ma'am.
this
Yes.
limit will be something fluctuating.
Understood, ma'am. Yeah, no need to explain option C also. Yeah, understood. I got my mistake.
Okay, so it's clear for all of you, right? I mean, now, up to now.
No.
Okay. So what's the next out?
8th question, ma'am.
8th question. Yeah. What is the problem here?
It's a very complicated question. If I solve, ma'am, could you like?
Yeah, sure. So what is given here? We have f of x plus y equals to fx fy for all xy, and we have given this values, and we have to find f dash 9. So the first remark is, because they directly ask you to find f dash 9, that means you have to clearly assume that f dash 9 exists, right? Otherwise you cannot find it, right? So this is our first assumption. Okay, fine. So this is the first assumption, that f dash 9 exists. Otherwise we cannot find the value, right? So because this is our aim to find the value, so first we assume that f dash 9 exists. Then we will follow that definition. What is the definition of f dash 9? limit h tends to 0, f of h plus 9 minus f of 9 by h, right?
Yes,
Now
ma'am.
we can apply this formula here. So we will get f of h, f of 9 minus f of 9 by h, right? Now we can take this f of 9 common, right? So we will get f of 9 limit h tends to 0, f of h minus 1 by h, right? Right? Up
Ma'am,
to now,
from where this
yes.
h plus 9 and this all came?
So h plus 9, then we will use this formula. I mean, this is true for all xy, right? So we can apply this formula. I mean, f of h into f of 9. Then here we have f of 9, here also we have f of 9. So we can take f of 9 as common. Then because it's independent of h, right? So we can take this outside the limit. Okay.
We are taking h as any discrete value from R.
Yes. I mean, yes, h is some real number which is tending to 0. So this is true for any xy belongs to real number, right? So h is a real number which is close to 0. So we can apply the formula for this. Okay. Fine.
Okay,
Fine.
okay, ma'am.
Yes, ma'am. Ma'am, can
Yes,
we
ma'am.
now in this step can we say that f of 0, like for f dash of 0?
Yes. So this will be f dash of 0 because we need if dash of 9 exists, that means this limit should exist, right? That means f of 0 should be equals to 1, right? Otherwise this will not, we will not get 0 by 0 form. In that case we cannot apply L'Hospital rule. So if it is not in 0 by 0 form, then the limit will not exist. So it will imply that f dash 9 doesn't exist. But as per our assumption, because f dash 9 exists, so f of 0 should be equals to 1, right? Clear? Is the step clear? If not, then you can ask.
Yes, ma'am. I understood, ma'am. We will substitute indirectly. This will be equal to f dash of 0, right?
So yeah, so we can rewrite it as h plus 0 minus f of 0 by h. So this will be f dash 0, right?
Yes, ma'am. Ma'am, if you don't mind, once could you go one step back and explain the indefinite, like why are we assuming, if you can?
This one. This step.
Yes, ma'am. Yes, ma'am.
Why are we assuming this one, right?
Yes, ma'am.
Okay. So in the first step, we assume that f dash 9 exists, right? So in order to the existence of f dash 9, automatically this limit also should exist, right? Otherwise
Yes,
f dash 9 will not exist, right? So this is again by the assumption that this limit will exist. Okay, but suppose f of 0 is not equals to 1. Okay, in that case this portion will give something finite, right? Non-zero finite, correct? And this portion will give 0. So we will find some non-zero constant by 0. So this will imply the limit will not be defined, right?
Yes, ma'am. Okay, now I understood, ma'am. Yes, ma'am. Okay.
Yeah. So from the
To
upper
make it
portion,
existing, we made few assumptions. Okay, yes, ma'am.
Yes. Just we want the limit to be something existing finite number. So we have to assume that this is in 0 by 0 format. Otherwise, it will be some finite number by 0 format, which is not defined, right? So in that case, the limit will not be defined. But by our assumption, the limit is defined. So here we will assume that f of 0 is equals to 1. In that case, we will get 0 by 0 form. Then we will apply L'Hospital rule. Then we can find a defined limit, right?
Yes, ma'am. Yes, ma'am. Got it, ma'am.
Okay, so it's totally clear to all of you, right?
Yes, ma'am.
Okay, very good. So then we can just directly put the values. So we will get 6 into 24, right? So it will be 24, right? So the value of f-9 is 24. Is it clear?
Yes, ma'am.
Okay.
Clear, ma'am.
Yeah. So we can, yeah.
Question number 4. Actually, I got not. I haven't got the right answer. Actually, this sum also came in the last year exam or one of the previous papers.
Can you repeat? I just missed. Yeah. Question number 4.
Actually, I got the wrong answer. So
this one. Hello.
Yes, ma'am. Yes, ma'am.
Yeah. You got the wrong answer.
Yes, ma'am.
Okay. So let us solve it. So we have, this is the function, and we have to calculate this. So we have root 8 limit extending to 1, and f of this is 9 minus x square, and just put here. So it will get root over 8 by x minus 1, right? So if we apply, if we just put 1 instead of x, then clearly we will get 0 by 0 form, right? Root 8 minus root 8 by 1 minus 1. Okay. So this is in 0 by 0 form. So we will clearly use L'Hospital rule. So what is L'Hospital rule? It will be equals to the derivative of the functions, right? So derivative of x minus 1 will be 1. And derivative of this function will be 1 over 2 into 9 minus x squared minus 2x minus 0. Right? Right?
Ma'am, can you please explain that step again? How to differentiate? I'm very new to this one.
Okay. So to differentiate this function, we have to use the chain rule. Okay. So what is the chain rule? If we have f of g of x, so the differentiation of this will be f dash of g of x into g dash of x, right? This is the chain rule, right? So if we have root over of x, what is the derivative of root over of x? This is 1 by 2 into root x, right?
Okay.
And now again, if there is some function other than this x, then we have to derivative this x, right? So if we just take it as y, suppose, okay, so we have root y, right? So the derivative of root y will be 1 by 2 into root y. Okay, so this is our y. Now we have to again differentiate this function. So what is the derivative of this function? Minus 2x, right? So just I wrote minus 2x here.
Okay.
Right? Okay. So now we can just directly put the value. So we will get minus 1 over 8, right? So minus 8 will be cancelled out, and the answer will be minus 1. Okay?
About the degrees of root x, right? So how many those things we need to know? Because we mentioned that d by dx of log x and d by dx of e power x sin x cos x. Is it anything, any set of things which we need to remember, at least for this exam, so from the exam point of view?
Your voice is not clear, but what I can guess, you are like just saying about the chain rule, right?
Saying
yeah. So yes.
Some exam point of view, he was asking, ma'am.
Okay,
No,
so
it's asking like, for example, ma'am, you said that d by dx of root x equal to 1 by 2 of root x, and then for log x you said that if I differentiate it will be 1 by x, and for e power x it is simply e power x. So like that, ma'am, is it like set of things which we need to remember, at least for, because doing this and then remembering.
Yeah. For the exam, you have to remember some formulas. You have to directly apply some formulas. So these are some basic formula. Just you have to remember these formulas. This is what you were asking, right?
Yeah. So is there any around like list of things which is there in some web, some page, or like is there any document or something where we can go through and then remember that?
See, if you are talking about the limiting formulas, that means you have 2 to 3 formulas using your sin x by x, cos x by x, tan x, tan inverse x by x, or u power x plus 1 by x power x, or log x plus 1 by x. These are some typical formula. So all of this formula, you can just apply one step of L-Hospital rule and solve. So just with this, you can keep it in your mind. And these are just basic formulas you have to remind. And for the derivative, chain rule is something general, right? So you just you don't need to like keep it in your mind. But n into, I mean, x power n equals to n into x power n minus 1. This is a very basic formula, and you can apply this formula for most of the thing. Other than that, exponential, logarithmic, cos x, I mean the trigonometric functions. These are some thing, and if you can just remind them, this trigonometric, exponential, logarithmic, and the general functions, these are enough.
Okay.
Okay.
Yeah, thank you.
Okay. Yes. What is the next doubt? Anything in 8.3?
6.4, ma'am.
8.4.
Yes, ma'am.
Which one?
1 minute. Second question.
Okay. What is the problem in second question? I mean, you solved it.
Yes, ma'am. But tangent of parabola, that part, it's new. Like it's not from the.
Okay, so a tangent of parabola means you have to, I mean, calculate the equation of the tangent. So you know what is the general, what is the general equation of a tangent at some point, right? Do you know?
Yes, ma'am.
So you just covered in the submission. Okay, so I will solve for one example, and you can solve for the another one, right? So this is the given function. This is for the first option. So we have the function as in this form, and what is the equation of tangent? Suppose at A. Just tell me.
F dash of A into x minus A
Plus f
plus
of A, right?
f of A. Yes, ma'am.
Yeah. So we have this parabola. So what is the vertex of the parabola? If we have in this form, the vertex is h comma k, right?
Yes, ma'am.
Okay. So the vertex, we have to calculate that. Means our equation is y equals to f dash h x minus h plus f of h, right? Right? So at the vertex, we have to calculate. That means we will take h. Okay?
Okay.
Yeah. So now you can calculate f of h. So what is f of h? Just put, this is your function f of x equals to this a plus this into plus k. Just take the k here.
Yes, ma'am. We'll get k as the value if we substitute h, f of h.
Yeah. So this will give us k, right?
Yes, ma'am.
And what will be the value of f dash h? F dash h will be, f dash x will be 2a x minus h, right? You just differentiate this function.
Yes, ma'am.
So f dash h will be, just put h here. So we will get 0, right? Right?
Yes, ma'am. Yes, ma'am.
So this will be 0. So we will get y equals to k. This option is correct. Okay. So similarly for the second function also we can calculate. Now you can do it by your own, right?
Yes, ma'am. I understood, ma'am.
Yeah. Very good. What was the next?
Linear approximations. Sixth question, ma'am.
Ma'am, sorry, in the same
Okay.
8.4,
Hmm.
can you go to the last question, ma'am?
Last question means question number 8.
8 and 7 and 8, both are same. So now the question here is like, what I don't understand this question is, what is the A here or H here?
I mean, you have to find approximate value of the given, root over for the first question 4.4 using the linear approximation, right? So this is just what I just told you during the linear approximation portion. You have to calculate the linear approximation, and if you, at the point 4, if you can calculate the linear approximation, okay, then the function will give approximately same value as the linear approximation near the point 4, right? So if you take x equals to 4.4, the value will be approximately same as the linear approximation at near the point 4, because 4.4, that means you are taking some point which is really close to 4, right? So the difference between 4 and 4.4 is 0.4, which is really close to 4, right? So
ma'am, it is root over 4.4.
yeah, so our f of x is root x, right? This is our function.
F of x is root x.
Yeah, so just let us do it step by step for the first function, and for the second function we can do it similarly. Okay,
Ma'am, we should substitute like x is 4.4, then
yes.
Oh, okay. I was doing root over x of root over 4.4.
No. Okay, just let us do it step by step. Okay, so there they said that using the linear approximation at x equals to 4. Okay, so obviously our first step is we will calculate the linear approximation as x equals to 4, right? So the equation is similar as the tangent. That means f dash 4 into x minus 4 plus f of 4, right? So then what is f dash 4? F dash x is 1 over 2 into root x. Right?
1 by 2 root x.
That means 1 by 4, right? So we will get 1 by 4 here. X minus 4 plus root 4 means 2, right? So this will be x by 4 minus 1 plus 2, right? So this is x by 4 plus 1, right?
Yes.
So let us denote it with L of x equals to x by 4 plus 1. So this is the linear approximation of the function fx near the point 4, right?
Yes.
So now if we take any point which is very close to the point 4, so we will get the, for this point beta, suppose beta is close to 4, okay?
Yes.
That means in that epsilon neighborhood of 4, okay? So the value of the linear approximation at the point beta will be almost similar to the value of the function at the point beta. Right? So we have to find the approximate value. Now this is
ma'am, could you repeat the last line, the equivalent line?
Yeah.
2 steps back.
So, yes. So this is the linear approximation, right? And what do we know that if we take any point, this is the linear approximation at the point 4. Okay. So if we take any point which is close to the point 4, so the value of linear approximation will be almost similar. That means approximately to the value of the function at that point. Okay. That means if we take any beta which is in the close neighborhood, it's epsilon neighborhood of the point 4. So for this beta, the value of the function L and the value of the function f will be almost same. Okay.
Okay, ma'am.
Yeah. So what is our fx? This is root over beta, right? just put the value, right? It will be root over beta, right? Now, if we take beta equals to 4.4, so clearly this is close to the 0.4, right? 4.4.
Yes.
Okay, just wait. Please wait. So we can now put 4.4 instead of beta, right? Then we will get root over 4.4 will be approximately L of 4.4, right? So this is our L of x. So we will just put the value here and we will get this, right? So it will be 0.1 probably, right? Okay.
Yes,
How
ma'am.
it is 0.1, ma'am?
I mean,
Yeah, 4.4 by 4 plus 1.
2.1, ma'am, will be getting.
okay, 2.1. Yeah,
2.1.
yes. Yeah, correct. 2.1. You can check the answer. What is the answer?
Yeah, 2.1 only.
2.1.
Yeah. Yes. 2.1. This is the answer. Okay, so the process is clear, right? I mean, this is how we can solve. I mean, just calculate a linear approximation, and at some point which is close to the point of the linear approximation, you can just approximate the functional value.
Ma'am, what is the f dash of x of 1 plus x power whole power 4, ma'am? Like derivative.
F dash of
1 plus x whole power. No. Yes, ma'am. Okay, no, I got an idea, ma'am, how to do it.
Okay.
No problem.
Just in this, you use the chain rule.
Can I do it in multiplication product form, like 1 plus x whole square and into 1 plus x whole square?
Yeah, surely you can do that. But the thing is, it will take more time. It will take more time.
Oh.
But just use the chain rule. So take it as y power 4 and y equals to x plus 1. Okay. So y power 4 will be 4 into y cube. That means 4 into x plus 1 cube. And the derivative of 1 plus x is 1. So this will be 3 into x plus 1 square. Okay.
Ma'am, I couldn't get it. Could you please solve it? Yeah.
I mean, just if you have something like that, just take this x plus 1 as some single variable just for y. Just you have imagine it. Okay. Then y power 4, the derivative of this will be 4 into y cube, right? And then we have to differentiate the y. That is y dash. Okay. My 4 and y are same. Sorry. It's fine now.
If we differentiate y, then it will become 1 plus x whole cube only, right?
That means no, y equals to 1 plus x. So y dash will be equals to 1.
Okay. Okay, ma'am. Now I got it. Okay, sorry.
So
Yeah.
it's f of g of x form. So f of x is x power 4.
Yeah.
Y g of x is 1 plus x.
X plus x. Right. Yeah.
Okay.
Right.
So it is f dash of f g of x plus g dash of x.
Into g dash of x. Yes.
Into g dash of x. Okay.
Yeah. Yes, correct. So if you have this type of thing, never use multiplication rule, because you can solve it using multiplication rule, but it will be time taking, right? So if in the exam you have to save your time, so better use the smallest way, right? So just use the chain rule to solve this type of thing. Okay, fine.
Yes, ma'am. Could you solve 6th question, ma'am? Like, how do you solve 6th question? There are many questions.
Okay. So what is the 6th question? Suppose the tangent of the curve represented by the function f at a point 1, f of 1 is given by the equation this. Okay. So we have to find the value of f of 1. Okay. Okay, so clearly the first step is we have to calculate the tangent of the function at the point 1 comma f of 1, right?
Yes,
And
ma'am.
it's given by the equation. So what should be the first thing, like what is the first thing should come to our mind is we have to calculate the equation of the tangent at this point, and then we have to compare this equation with the new equation, right? So then what will be the equation at the point 1? This is nothing but x minus 1 f dash 1 plus f of 1, right?
Yes, ma'am.
So this is equals to 3x plus 2, right?
Yes,
So
ma'am.
we will get f dash 1 x minus f dash 1 plus f of 1, right?
Yes,
So
ma'am.
if just so just take it as coefficient of x, and this is as our constant term, okay? And we will equate this to equation. Then we will get 3 equals to f dash 1 and f dash 1 plus f of 1 equals to minus 2. Fine up to now?
Yes, ma'am.
Yeah. Then just put 3 here. So we will get 3 plus f of 1 will be equals to minus 2. Then f of 1 will be maybe equals to minus 5. So is it the answer?
5 is the answer, ma'am.
Okay, then maybe I made some mistake. Oh, sorry. 5 will be the answer. I just took a minus here. This should be this. Wait. Sorry. So what was the y equals to? X minus 1 f dash 1 plus f of 1, which is equals to 3x plus 2, right? So this will be x into f dash 1 minus f dash 1 plus f of 1, right? I took minus f of 1 that time, maybe 3x plus 2. Now we will compare the coefficient. So this will be equals to 3 and this term will be equals to 2. That means f of 1 is equals to 2 plus f dash 1, right? And which is basically 2 plus 3 equals to 5. Okay.
Okay, like for any value, can we compare directly like that, ma'am? Like
Yeah.
taking for a few questions, they're asking f dash of x value, and like in practice questions, if we go through, I was
Yes.
confused over there. Okay, ma'am.
No, you can compare. So let me just briefly give you an idea. I mean, you can compare, but not every time. So if you have, because here we have this, do you have Maths 2 course? Or do you have any idea about vector space and basis?
Yes, ma'am.
Okay, right. So clearly this is in R2. I mean, this is a vector space in R2, right? And the basis here is 1 comma x, because we are taking a linear equation, right? This is the basis, right? So
Yes, ma'am.
we can compare if because x and 1, these two are linearly independent because this is the basis member, right? So that is why we can compare. I mean, if it were not linearly independent, then we cannot compare. But if you have some equation, then 1x, x squared, these things are always linearly independent, right? So in this type of case, we can always compare the coefficient. So in short, you can compare, but the logic, I mean, the mathematical reasoning, I mean, yeah, this is the mathematical logic. I mean, if this is linearly independent, okay, then you can, I mean, if you just take this in one side, then you can take x common, and then you can take this constant term. So because x and 1, these two are linearly independent, so the coefficient will be individually 0, right? That means they will be same, so the coefficient will be same, right? I mean, the I mean, f dash 1 minus 3, it will be 0 if we just take x here and then take x common. Am I clear with the word?
Yes, ma'am.
Yeah.
Like somewhat.
So basically,
Yeah,
this
understood,
is,
ma'am.
you got my point, right?
Yes, ma'am.
Okay. I mean, just I mean, if you can always compare. You can compare. You don't need to think it about twice. But
Yes,
this
ma'am.
is the logic.
I got this doubt because can we compare in fifth question? Luckily, it was like coincidence where it matched. So I thought my way is wrong.
Yeah.
Then I stopped doing these questions. Sorry.
No, it's fine. So you can take just I just told you the logic behind this step, so that you can just like before doing this type of take, you just think it once. Is it valid or not? Okay, but in maximum of time it will be valid. So you no need to be worried about it.
Okay, ma'am. Yes, ma'am.
Yeah. Okay. What is the
question, ma'am?
Yeah. Next question. Which
Fifth
one?
question, ma'am. Fifth question.
Fifth. Okay. So yeah, what's the problem in fifth one?
I got stuck in this question. Fifth
Okay.
and sixth, but sixth is clear.
Okay. Okay, let's solve fifth question together. I will not solve. You have to solve. Okay. So let is be a differentiable function at a x equals to 1. So we have f is differentiable at 1. The tangent line to the curve represented by the function at the point 1, 0 passes through the point. Okay. So we first, the tangent line of the function f at 1, 0. So what is our first point? We have to find the tangent line at 1, 0, right? So what is the tangent line at 1, 0? You just calculate and let me know the thing. I mean, what is the equation? Y equals to?
y2 minus y1 divided by x2 minus x1 tangent.
X minus 1 plus f of x, right? This is the equation of tangent at x equals to 1, right?
Yes.
Yeah. And the first thing is clearly this point and this point. I mean, this is the tangent line and this line passes through these 2 points, 1, 0 and 5, 8, right? So we will, I mean, if this
m equal to 2, ma'am, I have solved. Y equal to line will be 2x minus 1.
2x minus 1. Okay, let's solve. So the thing is, because this 2 point is on the line of the tangent, I mean over the tangent line, so this will satisfy the tangent line, right? So we will get this. That means f of 1 equals to 0. And
2x minus 2, ma'am. Sorry.
2x
minus 2. You have to. Yeah.
Is it fine? Okay.
Yes, ma'am.
Okay. Okay. So in the next, this point, if we just satisfy this point, so we will get 8 equals to f dash of 1, 5 minus 1 plus 0, right? So x will be f dash 1 into 4. So f dash 1 will be 2. Fine?
Okay, ma'am.
So I just take 2 common, x minus 1. So this is 2 and this is 0. Just put here. So the tangent will be x, 2x minus 2. Very good. This is the answer. Okay.
Ma'am, the first line y equal to f dash 8. After that, you put x.
Your voice is breaking. Can you be louder?
The first line, ma'am, y equal to f inverse of 1 followed by x. That is what
F dash of 1. F dash of 1.
Okay. F dash of 1 after that.
The first line, right? So the first line is general equation for the tangent at the point 1. Okay.
So what is the second parameter?
Yeah. So the second and third line, we have the clue that the tangent line, that means this line passes through this point and this point. So this this 2 point will satisfy the line, right? So y means the y coordinate, and instead of x, we will put the x coordinate. Okay, then we will get the value as same. So you just check. I just put y coordinate instead of y and x coordinate instead of x. And for both the function, both the point will satisfy the function. And for both the point, we will get two different conditions. And using the condition, we can find the value of f1 and f-1.
Ma'am, instead of substituting, can we directly compare with the line equation at the above?
Yes,
2x minus
yes. Just 2 point term, right? I mean, using this 2 point, we can first calculate the line, then we can equate it, and then just compare
Yes.
the coefficient. Yes, this is also another process. Yeah.
So the f dash of 1 is going to be the slope of the tangent line.
Yes. Okay.
Yes, ma'am.
Okay. It's fine for all of you? Yeah.
Yes, ma'am. Practice assignment, can you go, ma'am? Like if it's completed.
Yeah, sure. Okay. So is there any problem in activity question? Anything in activity question? Anyone?
Excuse me, ma'am.
Yeah.
Ma'am, in 8.3, question number 6.
8.3, question number 6. Yeah.
I don't know how to derivate that log 5 to the base x, ma'am. The another one I did actually.
Okay, so for this type of thing, just apply log formula. I just give you hint. So you can write it as like that, right?
Okay.
So then log 5 is a constant, and you have to just derivative this function, right? Now, can you differentiate it using the chain rule?
I mean, instead of that, can we change of base and value, like log of x base? Log of base of x5 is equal to 1 by log of base 5x.
Minus of this, right?
Yes, ma'am.
That way,
that's a general formula given actually.
Okay, 1 by log x to the base 5.
Yes.
Okay.
This is also possible. I mean, this.
Okay.
Yes, then we have a log for that x base 5 or x base a. We have a formula, direct formula.
Yes. So this is also another form. I mean, you can just you can solve it in so many ways. So whichever is comfortable for you, you can use this. Okay.
Okay, ma'am. Then the fourth question, you already explained, but my doubt is
this one. Yeah.
Fourth question, ma'am.
Yes.
This one, after applying the value of f of x minus f of 1 by x minus 1, I used the quotient rule to solve, ma'am. So I got stuck somewhere. Do we need to use the quotient rule or just simply?
No. You cannot solve it using the quotient rule because it's giving 0 by 0 form. I mean, if it is something defined, I mean finite, then you can use the quotient rule. But if it is in indeterminate form, then you have to use the L'Hospital rule.
Okay.
Yeah. Just use the L'Hospital rule.
Okay. Thank you.
Yeah. Okay. So any other doubt in activity questions?
Ma'am, can you find that value in question number 6? Log.
Okay, sure. So what I just told, we can do this in this way. Then I will differentiate this. So this is as a constant term. So this will be, first we can differentiate 1 by x, which is nothing but what? What is the differentiation of 1 by x? This is x1
minus 1.
minus 1 by x square, right? That means if this is our x, then it will be minus 1 by log x square, right? And then we will differentiate this log x, which is nothing but this, right? 1 by x. Differentiation of log x. Is it clear?
Yes.
Yeah. And we have log 5 here, right? So just if we write it simply, we will get minus log 5 by x into log x square, right?
Yes.
Yeah. Now we can take 1 log x. So log 5 by log x will be log x base 5, right? That means minus log x5 by x log x. Is it clear? It's this step from this to this.
Yeah.
Now here we have e, I mean 1, right? That means log e. E base e. That means it will be 1, right?
1.
So we will again get then x5 log x e by x. That means this one.
Okay.
Okay.
Thank you.
Fine.
Yes,
Fine
ma'am, thank
for
you.
all of you. Okay. Okay. So is it fine for all the activity question? Okay. Then we can move to the practice assignment. So what are the doubt in practice assignment?
Fifth question, option number 2, ma'am. Like I understood 50-50, but I want a proper explanation if possible, ma'am. Fifth question, option number 2, it's wrong.
Yes.
This one.
Okay. So we have given fx and gx. Fx is e power x minus 1 and gx is x. So fifth question, option number 2. Okay. So here the same, just she asked about it, no? She used the quotient rule and she is not finding the limit. So this is the same thing. I mean, here if you just put the 0 instead of x in f, I mean f of 0 will be 0. G of 0 will be again 0, right? So if you use the quotient rule, you will get 0 by 0 form. So from this, you cannot find the limit. You have to use the L'Hospital rule in this type of case. So if you apply the quotient rule here, I mean this type of thing, then you will find 0 by 0. So which is clearly not the limit. So you cannot apply this. Okay. I mean, if you are finding something non-zero finite, then only you can apply the quotient rule. Otherwise not. Okay.
Got it, ma'am.
Yeah. Okay. Next.
Ma'am, comprehension type question. Like the 3 questions. That's it, ma'am, for today.
Okay. Okay, very good. You went through all the questions. I'm so happy. Yeah.
Only this question is painful in the whole 8th week, ma'am.
Okay. So what is the 6th question? So we have if the function f and g, the profit company A, B respectively, okay, are known to be continuous at t equals to 3, then what is the given? Okay. But we have given the profit of company A with respect to time is given by the function ft. Okay, so the profit is given by the function f, that means the first function for the company A, and for the company B, the profit of the company B with respect to time in months is given by the function g of t as follows. So the second function is profit, function of profit for the company B. Okay, thus given that if the function ft and gt denoting the profit of company A and B respectively, okay, known to be continuous at t, then which of the following is true? Okay. Okay. So here is given that both the function f and g are continuous at the point t. Okay. That means at the point 3. Okay. That means what do we have by the definition? If f is continuous at 3, let us do it step by step. If f is continuous at 3, then what do we have? Limit extending to 3 minus f equals limit extending to 3 plus f equals to f of 3, right?
Yes, ma'am.
Yeah. So what will be limit extending to 3 minus of f? We will use this first, right?
Yes, ma'am.
Okay. So what will be the value?
It's coming 0 by 0 form, ma'am.
Okay. 0 by 0 form 1 power n minus 1. Okay. So 0 by 0 form means we have to apply the L'Hopital rule, right? So if we
Yes, ma'am.
apply L'Hopital rule, then we will get n into t minus 2 over n minus 1, right?
Ma'am, is that the differentiation? Like, need not do more. Like, okay.
No. Yeah, this is a differentiation. So this is the differentiation, okay? First derivative, we just have to calculate because the derivative of t minus 2 will be 1 into 1. So it will be the, okay, so we are applying the chain rule again, same. It's fine?
Yes, ma'am. Okay, I agree. Yeah. Okay.
Now just put 3 here. So we will get 3 minus 2, that means 1. That means this will be clearly n, right?
Yes, ma'am.
Yeah. Okay. So what about the second thing? 3 plus.
It will belong to 3 only, like
Yeah.
t value. Yes, ma'am.
Is this option correct?
Yes.
Okay. Similarly, can you calculate for
ma'am, I have to check. Please. I don't remember. I'm not. Please go.
Yeah.
Okay, no problem. We'll check later.
Just okay, we can check, no problem. Yeah, n equals to 3. Okay. Similarly, can you calculate for m? I'm waiting. You just calculate for m and
Yes,
let me
ma'am.
know is
What
it
I did it for m, ma'am. Like we'll be equating 3t power m,
Yes.
which is equal to 3t square,
Yeah.
which I've done. Is it right, ma'am?
Yes, same. Similarly, you have to do. So
Okay.
are you finding the option as 2?
Yes, ma'am.
Okay, that's fine.
Okay. Seventh question. Seventh and last.
Okay. Okay, assume G is to be continuous at 3. G is continuous and 3. This is what we have given. That means we have, by this statement, they have basically gave us hint that t tending to 3 minus g of t will be equals to g of 3 will be equals to limit t tending to 3 plus g of t, right? This is given in the question. Now using this, we have to conclude something about the options. Okay, so what is the first option? We have limit t minus 3 t tending to 3 minus gt minus g3 by t minus 3 is equals to 18. Okay, so clearly it's in 0 by 0 form, right? Because from
Yes,
this
ma'am.
portion,
Yes,
from
ma'am.
this portion, it is clearly 0 by 0 form, right? So we can apply the L'Hopital rule, right? So what will be the t tending to, after applying the L'Hopital rule, we will get this, right?
Yes, ma'am.
So it will be equals to g dash of 3.
Yes,
Okay.
ma'am.
Now you have given what is g. Now can you just differentiate it and calculate the value at 3 and let me know what is the value right now?
Actually, 1 minute, ma'am. I'm not having pen and paper.
Yeah, just bring your pen and paper as well. What is our g? This is our g, right? So calculate g dash and at 3. I mean g dash 3 using your definition.
So it will be 3t power m, right? G
Yes.
at 3.
Yes, 3t power m. And
m
this
times
is
3 power
this,
t m minus
yes,
1.
yes, yes.
So m is equal to 2 from
M
before
is
question.
equal to 2. Yeah. That means 6 into t power m minus 1. And t is 3.
Yes, ma'am. 2 into 9, 3,
6 into
27. 27 times 2 I'm getting.
so
I guess I made a mistake somewhere.
g dash of 3, right? So your g is 3 t power m. Is this a function?
Yes, ma'am.
Okay. So 3 m t power m minus 1. And we know m equals to 2, right? And 3 equals to t equals to 3. So just put 3 into 2 into 3 power 2 minus 1. That
Yes,
is 1.
ma'am. Yes. I got it. 18. Yes, ma'am.
Now, can you check the other option with using same type of logic?
T minus you are asking. 3 minus.
All, yeah, 3 plus and 3
3 plus,
minus.
sorry.
For 3 plus and 3 minus, you have to do the, okay, because the first option is correct, automatically the fourth option is incorrect, right?
Yes, ma'am. Ma'am, could you do a differentiation for 3 plus, could you go up for the function once? Could you show the function?
Yeah, sure. Okay, so you have, so similarly, it is again in the 0 by 0 form. So clearly we have to do the differentiation, right?
Yes,
For
ma'am.
3 plus. And so we have this function. I mean, you have g of t equals to t cube minus
minus
okay,
9.
sorry.
That's 27.
We took this as t minus, but this should be in 3 plus. I mean, this should be the case of 3 plus. Okay, so in 3 minus we will take this one.
Yes, ma'am. Oh, yeah.
Okay, so it was the answer for 3 plus. So we
Yes,
will
ma'am.
check. It was 18.
3t square only, right, ma'am? Here.
Yeah.
The differentiation.
That is the
Okay. No need to
second
solve it,
one.
ma'am. I understood now, ma'am.
Okay, you
Okay,
got
yes,
right?
ma'am.
So the hint is, I mean, you can apply a cube minus b cube, cancel t minus 3 the term, you will get simply a polynomial. Just solve. Did you get?
Need not it's differentiation only, right, ma'am?
Yeah, you have to differentiate this function, right?
Yes, ma'am.
Yes. So
3t
you can,
square.
I mean, you have to differentiate the whole function using the quotient rule. So what my suggestion is, just you can explain this is as t minus 3 t square plus 3t plus 3 square. Then you can cancel this and this.
Oh, ma'am, is it different? Why aren't we like denominator 3t square minus 0 by 1? Why isn't it the differentiation?
What?
Why is it not the differentiation should be like what I am thinking is 3t square minus 0 divided by 1.
Oh, okay, so this is something different. I mean, in that case, f by g, we were applying, when we were applying L'Hospital rule, while calculating the limit. Here there is nothing about limit. I mean, we are calculating the differentiation. I mean, directly we are differentiating the function. So you have to quotient rule for the differentiation. I mean,
then previously in previous question when we are solving n equal to 3, how did we do that then, ma'am?
In this portion, see, after this is in 0 by 0 form, right? This is in 0 by 0 form. So after using the L'Hospital rule, we get this limiting value is equals to g dash 3. Okay. Now you have to calculate g dash 3, where g of t is t cube minus 3 cube by t minus 3. This thing are not similar. I mean, you are not calculating limit here. So this is not in, I mean, f by g form 0 by 0. So just calculate the derivative of f and g differently. I mean, here there is nothing limit. I mean, we are
Okay,
calculating it
now I get it,
directly.
ma'am. We are calculating only g of t, then we are
Yes.
substituting over there, so it's
Yes.
not coming under limit. After substitution, we're getting into
Yes.
limit.
Yes.
Okay,
Correct.
okay,
Correct.
ma'am.
We are not applying limit. We are
Understood.
first we have to calculate the derivative, then we can substitute the 0.3. Okay, so I mean, using the quotient rule of derivative, you have to calculate the derivative.
Understood, ma'am. I'll work on it. If I have any doubt, I'll return back.
Yeah, you can let me know.
Yes.
Also, I will cover this questions, and I will try to upload the video in 2 to 3 days in your playlist. So you
Okay,
can
ma'am.
also go through them.
That's good, ma'am. Yeah.
Yeah.
Week-8 wasn't uploaded yet.
No, yeah. In 2 to 3 days, we will upload Week-8.
Okay, ma'am. Then it will be fine. Yeah.
Yeah.
Yes.
So you can go through them if still there is a problem. Okay.
Yes, ma'am. That's it, ma'am.
Okay.
I'll do the last question. No problem.
Yeah. You can try it in similar.
Yes, ma'am. You said you'll upload, so if I'm having any doubts again, I'll just go through the video.
Yeah, sure.
Yes, ma'am. Thank you, ma'am.
Yeah, welcome. So what about others? Is any problem in practice assignment? If still it's pending, then you can go through the problem first. If you are facing doubt, you can also go through the videos. I mean, I will cover all the practice assignments. So is it okay for everyone? If you have doubt, you can ask. Otherwise, you can leave.
Thank you, ma'am. There are no more doubts.
Okay.
Thank you, ma'am.
Welcome. Yeah, welcome. Okay, so we can close this session because you don't have any doubt. Okay, so good night, everyone. Yeah.
Ma'am.
Yes.
Ma'am, I just have a general doubt regarding
sure.
the question, ma'am.
Yes.
Is there any specific link for quiz 2 papers, ma'am? Previous year papers, or how do I access it, ma'am?
Okay, so about it, I am not very sure. I mean, is there any specific link or not? I mean, I am not sure, but yeah, in the next session, maybe, or in the TA session, you can ask the TAs. Or in the next session, I will provide you the information. Is it fine?
Okay.
Yeah,
ma'am.
sure. Yeah.
Thank you so much.
Yeah, sure.
Okay, ma'am. Thank you, ma'am.